Hi, everybody. We'll wait a few minutes before we start lab today. I want to share with you if you're interested in, well, there are two things. I don't know if you're interested in hackathon, but there's one. So you can join leagues or participate in hackathons because there are a lot of employers looking for potential employees in these things. I'm sorry if you're sick. The weather changes probably got everybody a little down. And then if you're interested in cybersecurity, National Cyber League just started. So hold on, let me give you the link. I know that everybody's busy, right? But if you have time, you can join some competitions, get some recognition. And then I want to share with you Microsoft Imagine Cup. So you can win some money. So the last year competition, or I don't know, yeah, last year competition, I think the person that got first place is a student from UCR, if I'm correct. He created an app to measure blood sugar, which, you know, Microsoft gave him the winning prize, but you can check it out. And so you can, I think you can, a team can win $8,000. And then you get 2 weeks at Microsoft to be mentored by the executives. Oh, sorry. Yeah. Here, let me resend that. Okay. And then if you want to practice your programming, I'll send you a link and then we'll start. Okay, so there's some links for you to check out when you have some time. And yeah, Lachelle, sorry, the chat was coming through so fast, and as I was typing it, Zoom changes the destination or the recipient. Okay, so there's some links for some competition if you're interested. I used to coach for one of the team from Moreno Valley for NCL, which is the National Cyber League. We don't have a team for Moreno Valley College this year because I guess, you know, time just passed by and I just didn't have time to organize a team. But I know RCC is competing. Skip Berry is the lead faculty for that. He's coaching in that. and then he's able to get some funding for the vouchers. But some of the other stuff that I put on there, you can check it out. It's free, so you can, you know, get together with your friends and start joining. Sorry about my dog. He's just barking. Okay, so let's talk about lab 4. This is a little bit different of a lab. Let me get into my courses here so I can show you. So try to use the module in the Canvas course room. That way you know what's due and what's not due in each of the unit. So just a reminder that we are doing a quiz by next week. So make sure that you complete the quiz. And then make sure that if you want to submit for the extra credit, you can. And there's a quiz 1 review game on our Canvas. So you just need to give me the screenshot of your score. And then if you have the highest score after the game close, I will send you an e-gift card via email. So you can get a chance to win some Amazon gift card, because that's what I use. It's the easiest. Okay, so I'm going to go into screen share. Please unmute and ask question if you want to ask questions. Give me 1 second. Okay, so you can download Lab 4. Sorry, I had some revision in this because I want to improve the lab. I added some videos regarding the permutation, and it was done for computer science. And it talks about the math concept with it, along with, you know, how to look at permutations when you're doing the decision tree, and what kind of algorithm that you should be implementing. It's not too long. When you get a chance, check it out. That's going to help you understand a little bit more on what we're going to be doing. So if you can download the Lab 4, and then what we'll do is I'm going to go over each of the exercise. Okay. So in Lab 4, we're going to use the algorithm STL, and for C++, each of the program that we're going to be using today is basically a pre-built, it's using the library to pull the function that was created. So in the first part, we're going to look at the next permutation. And the whole purpose in creating these programs is to see variations of the output, right, based on what we talk about is the combinations of the numbers and how they could be different from the beginning to the end, and how many of the variations should be using the permutation functions in C++ library. So when you're using the STL, you simply include algorithm at the top, like you've been doing with IO for the IO library. So at the beginning, it talks about lexicography, which is a way that we can rearrange the values or the characters in variations, so that way we can output and see the combinations or the arrangements of these values. So the implementation of the next permutation in that it would arrange based on the lowest possible order. So when you're looking at an array, let's say that we have an array with the values 1, 2, 3 to start, right? And we want to see how many combinations or how many or different variations that it's going to arrange the values 1, 2, and 3 throughout the program. So in the next permutation, what it's going to go through is that it's going to take these values and it's going to decide on the placement of the values going from left to right. And on the next round, as you can see, it's always going to be higher than the previous. So on the next permutation, what we're aiming to do is it's going to be larger, okay? So here it talks a little bit about the comparison. So what we want to do when you write a permutation program, the easiest way and the most efficient way is to really establish a sorting algorithm. So what we want to do is, if we are sorting to begin with, not in the array itself, but we implement the function to sort, where it would be ascending, meaning from going from the low to high, what we can do is we can utilize the values and be able to compare the sequence, right, for like 1, 2, 3, for the next outcome in the arrangement of the values, okay? So it's a way that we need to compare each of the element in the array based on the position, how it is ranging from one element to the next. And they cannot be equivalent. So we cannot have 1, 1, 1. They have to be different. So if we start out with 1, 2, 3, what we can do is we can see how the second and the third element positions can change. So when you do this, what it's going to do is going to take a look at each of the value, and it's going to use the comparison operator to determine what will be the greater permutation based on what is existing. So an example of this is if we're looking at the letters like G, F, G, okay? So the next permutation for that will be GGF, because G comes after F. So as you can see, the second placement here for the F, it's being swapped with the G because the second position needs to go higher, okay? And then therefore, since we only have 3 in that group, it has to place the F as the third position in that arrangement. And similarly, you can see with ACB, the next permutation for that, if we swap them, so A can go to B, right? Which in such that we have to move C, we have to rotate it back to A because we only have the 3 characters in the group to start with, and therefore it needs to have the C in the last position. So really determining based on the third position in that arrangement is going to be the second position in place. So what you have is here, it gives you a little bit more explanation on how it would arrange the values based on the given array, in that the elements, it's going to take a look at from the first to last. It doesn't matter how many you have, but it would be that we want to achieve the number of permutations based on n factorial, as we discussed on Tuesday. So let's say I have 7 elements. That means that I would have 7 factorial of 7, which means that I would have 7 times 6 times 5 times 4 times 3 times 2 times 1. And when you multiply that together, you get a number, and that's going to tell us how many arrangement it's going to go through to give you variations in the values that's in that array. Okay, so first, when you start writing the program, you have to keep in mind that this is going to be the number of output that we're going to have. And with the different type of permutation function, what we want to do is we want to allow it to first to start with sorting. Then we can create variations of the values based on the pre-sorted values. From there, what we want to do is if we start with ascending, in the case of next permutation, at the end of all the arrangement, it should go to the descending order. So if I have A, B, C, D, E, F, G to start, by the end of all my permutations, I would have from G going back to A in the descending sort. Okay? So, and here it gives you a note. It's saying that if the function can determine the next higher permutation, it rearranges the element as such that it returns true. If it's not possible, then it would return false. So it would only work if our next variation values would be higher, grouped together, that would be higher than the existing or the start. Okay, so what you have is, when you take a look at the beginning of the page, if you have 1, 2, 3 to begin with, the next higher would be 1, 3, 2, because if you look at that as a 3-character value, you see that 1, 2, 3 is less than 1, 3, 2, right? The way it's arranged. So in the next, if you have to start as 3, 2, 1, right? What will happen here is it's forced to go back to 1, 2, 3, because it has to rotate from 3 back to 1, and the 2 keeps its position, so the third position is determined by that 2. So we'll see a little bit more when we build the program, so you're going to see that every variation will be larger. Okay, so in this program, so I want to explain a little bit about the mechanism of this program. First, you have to include IO stream because we want to have output so we can see. And we want to include algorithms so we can use the library for next permutation function. In the main, we have an array, and the array contains integers. So we have to type in 1, 2, 3, 4. So right off the bat, we know that there are 4 elements in this array. And if you understand the mathematical calculation for this, you would know that this is the number of input that we have for our program, which is 4 elements. So our n value would be 4. Then the number of arrangements that we're going to get is going to be factorial of 4. So 4 times 3 times 2 times 1, which gives us 24, right? 6 times 24. So when you multiply to calculate the 4 factorial, you simply multiply 4 times 3 times 2 times 1, which gives you 24. And to start with our program, we want to issue the sort function here, and we want to be able to sort it. So in the case, this is already in ascending order, going from smallest to the largest. But in the case where you have an array that is not in order, right? Because in a set, we studied that, and we talked about a set doesn't have to be in any order. But let's say you have an array that doesn't have any order arrangement to start. What you can do is you can have it sorted, okay? So in this program, we simply have the sort here just to make sure that that's the ascending order. Then we want to output the factorial of 4 because we want to show that this is the number of, so it basically print the factorial of 4 possible permutation. We know it's 4 factorial because there are 4 elements. So it's going to print out that line, and then here's a do while loop, right? Now, the way that we can access each of the element is through the index. And so when we write the loop, basically that allows us to access the value in that array for each of the index. So we want to be able to access the value and print that out, saying that here is the elements of the array, right? And so that way we can print out the variations when it goes to the permutation. So we would start with 1, 2, 3, 4, and then we would have the function for the next permutation, so that way it would swap the position and rearrange it in such that each arrangement following the first would be higher. Okay. So after we had it sent through the loop, what we want to do is we want to print out, and we wanted to say after the loop, it would be this value, 0, 1, 2, 3, 4 index. Okay, so we wanted to see how it would permutate by interchanging the value within that array. Okay, any question? So let me get to my REPL real quick. So, and I modified this compared to last semester. So, you know, if you saw this last semester, it's a little different. Okay. This program is the same, but the assignments is slightly different. So, okay. So here's our program. And when we run this, so we can see a little bit more on how it's going to be. So if you can see here, it counted up to be 24 as we expected, because it's factorial of 4, there are 4 elements. So if you have 5 elements, that will be factorial of 5. If you have 20 elements, factorial of 20. So you have a much longer list of output. So with this, what we have is we started with 1, 2, 3, 4. Then what it's going to do here is that it's going to go to the next variation that's going to be larger. So if you're just looking at the last 2 value here, so let's say 1, 2, 3, 4, the next permutation, it has to go higher. So it would be 1, 2, 4, 3. Okay. Now we already maximize at 1, 4, 3 because there's nothing higher than that for us to go. We don't have a 5, we don't have a 6. So it has to change the second position, and it's going to go to the 3 after the 2. So it will be 1, 3, 2, 4. And then after that, right, it's going to have to change that to 1, 3, 4, 2. So what this does is it's comparing the values in specific positions, so in such that it would return true with the permutation that the next round is going to be larger. Okay, so in order to do that, we have to get it to access the elements in our array. And you can take a look at the documentation for how they write the template. It basically simply iterate and use comparison operator. And so in here, in the parameter, we want to pass the identifier for our array, and we want to specify that there are 4 elements in that array. So if you have 5, you would do a +5 there. If you have 20, you would do a +20 there, right? So that way it understands, right, that this is what it needs to do in the execution of that function. Okay? So when you get to the end of this, you notice that at the 24th permutation, it's completely in the descending order. So it's going from 4, 3, 2, 1. So in the next permutation, the purpose for this is to permutate through the values in your array, exhausting the value going from low to high with the comparison, and at the end you will get a descending sort. in value of your array as the last permutation. Okay, any question? Okay, so here's what we need to do for number 1. So you're going to use example 1, and here we have 4 elements. First, we need to calculate the variation of arrangement for the example 1. So we know that there are 4 elements. So with that, what we have is we would have 4 factorial, which gives you 4 times 3 times 2 times 1, which is equal to 24. Let me put it in purple, it's lighter. Okay, so which gives us 24 arrangements. Okay, and we know that each of the arrangement, they are distinct to the last, because order does matter with permutation. Okay, so now what you want to do is then you would input this program into your IDE or your online compiler. Okay, so make sure we check syntax. And it's not too long, so once you input your program and run your program, I want you to describe the arrangement of your elements, and notice that each of the arrangement output, what do you really see? One compared to the next, right? Okay. So here, what I have is I have the program created, right? And when I ran the program, I saw that this is where we started, 1, 2, 3, 4, because we forced it to sort, right? We had the sort mechanism right here. Okay. Because with that, that's when we're going to start with the lowest arrangement to begin with. Then from there on, it's going to access each of the element. So that way we can print it. Then we send it through the next permutation functions. And as you can see, one arrangement to the next arrangement is always higher. So if you have taken 17C, right, or you're in it now, they probably talk about the time complexity and how to really determine, right, what the outcome of your program. So this is linear. Now, when you also have things, nested loops and additional execution within, then that can change, and we will see some of that in, you know, like the is permutation when your big O is different. Okay. So it's simply accessing each of the element, and then it's going to take a look at how it would swap based on what would be less. Any question?
Yes, I have a question.
I'm sorry, I can't hear you clearly. Can you repeat that?
My question is, we have to write the program the same we see in an example. We have to modify the program, and what we have to do with the program.
You're still getting cut off. Say the last part again. After you write a program with the template, and then what?
And we have to explain when we see the output.
Yes, you have to explain what you see in the output. Mainly, I'm interested in how the output relate to next permutation. So the whole point in the next permutation is to really get it to have different arrangements, to produce different arrangement. And in each of the subsequent arrangement, that will be higher. And it has to use a comparison operator in that. So now with later on in the lab, you will actually write a permutation function. But to start with, I want you to see how you can implement the STL. Yeah, so yes, you just explain what you would see as the outcome in the arrangements, right? And as far as the output for each of the arrangement.
Okay, thank you.
You're welcome. Okay. Oops, sorry. So for B, 1B, I simply want you to run that program. Describe the arrangement of the elements from one to the next. What do you see? Is it larger, smaller, right? Now on part C, what I want you to do is I want you to test it. So I want you to replace the first two elements with a higher value than the rest. So if I have 1, 2, 3, 4, I can put 6, 7 in the front, or, you know, to see how what would be the outcome. The reason why is I want you to see how to test that next permutation function to see if it's still going to give you, right, from ascending to descending order in the permutation. So I'm going to do that real quick for part C. So simply you just have to use the program that you created. So let's say I wanted to minimize this and I want to make this 11 and 12, right? Oops. And that's higher than what we had started with in all elements. And so as you know, we forced it to sort first, right? And it's still going to produce 24 variations of the number. Okay. Then at the last variation, it's still in descending order. And if you're just looking at the first few, you can see it starts, since my 3 is the lowest in this group, right? We would have the 3, 4, 11, and 12 because we sorted. Then to go from 3, 4, 11, 12, of course, on the next variation, it's going to take out the 11, it's going to put the 12 in that place because this arrangement would be higher than the existing, the one to start with. Okay. So the 4 then is going to change with the 11 because that's the next highest number that we can go to is 4 to 11, right? Based on our new array here. And then from there, right, then the 4 is going to be replaced with or swap with the 12 because that will be the next one that's higher. Then after that, 11 is going to go to 12. And then here is 4 and 11. Okay. And then on the next variation, it will be 11, 4. Because this is higher than this. So therefore, you don't have 3, 12, 11, 4 before that. Because if you take a look at the arrangement, the number 5 is less than the number 6. And then after this, we exhausted the variations based with the 3 to start. So 3 is going to move to 4. And then it will put the 3 here, 11 and 12. And then 4, 3, 12, 11, 4. And you would start seeing a pattern, right, based on the group of the arrangement as it goes through. So in increments, you would see that. Okay. Now, all of these values break down to binaries ultimately at the start. So based on that, the computer, it sees the binary and it's going to say, is this binary less than this binary? Right? It has to, based on the given values in the array. Okay, so for C, I simply want you to replace the first 2 elements with the higher value than the rest to begin with. And I want you to rerun the program to see if you're still going to get the same number of arrangements. And is it still going to give you the descending at the end of the 24 arrangements? And is it still going to give you the arrangement subsequently that's going to be higher? Because we wanted to test the function to see if it operates appropriately, accurately. Any question? So after you completed the edit for the program with the higher values for 1C, take a screen capture, describe the outcome for the permutations. And you can use other number. I just put the 1 there so that way I can quickly edit it. But you know, you can use any values that will be higher. So why we have the after loop here, okay? The reason why is when you get to the end right here, we have to go back to the beginning. There's nothing else. It exhausted all the variations after the 24 arrangements. So we go back to the beginning again. Okay, so after all the permutations that complete the permutations, then we ended up right after that, it will be the beginning again. So because we exhausted all the movement with the variation so that way it's different. Okay. Any questions? So again, this is using algorithm STL, and you would see that in a few chapters, a few weeks, we would be using this. So for future references, you can look at, what would be some of the functions or the template that was built for algorithm, and so that way you can implement that for your programs. Let's say that you want to generate different combinations of blockers, variations of distinct passwords, variations of PIN number for, system login, stuff like that for the user. Now, we're not getting into random yet, but we'll talk about random down the line. But this is, something that you can use to really output different variations of arrangement and values. I should change this to 4. I'm sorry, the comment is incorrect for there. Okay, so no questions. We'll move on to number 2. And you don't have to include all the notes. The notes are there for you to look at, so, or the comments. Okay, so for the next one, this is previous permutation, so it's like going the opposite way. This is also included with the algorithm STL, and we want to have it where it would arrange very much like the next permutation, but in this one, what we're going to go is we're going to go from the high to low. Okay. So when it arranged the elements according to the last permutation sorted in descending order, so when it returned false. So when it's already in the descending, then what you have is you are going to go, because when it's already at the lowest possible permutation, then it's not gonna output. So what we want is we want to go from high to low, so it needs to get to the ascending at the end. And again, we would have the n factorial, so this will be the number of possible arrangements. So if you have 4 numbers, so then we would do factorial of 4, which gives us 24, right? So we would plug in the number of input, which is the n, the number of elements in your array, the number of elements in your vector, okay? So what we want is, if we started with the smaller sort, with the ascending, then it's going to look at the largest of the elements, so that way it's going to give you the largest first, and then it's going to go from largest to smallest. Okay. So here's our program. Let me open it up on Repo so you can see better. Very similar to the last one, but what we want to do in this one is we want to have a reverse sort. So we would start with high to low, okay? So no matter what you specify, or whatever values you assign in your array here, these two allows you to first sort it and then reverse your sort. Okay, so we have 1, 2, 3, 4 assigned to our array for the elements. Then we would start it with sorting it and then reverse it. So therefore we would have 4, 3, 2, 1 to start. So you want to have the reverse sort so that way you can start with a descending sort. Okay, and then if you start with the largest, what you can do is you can make the next iteration or the next arrangement smaller than it. Okay, so as you can see with the 1 here, you have 4, 3, 2, 1. And with the position of 2 here, the way that it would go to the next arrangement that would be lower, because that's the purpose of the previous permutation. It's looking at this. It's going to say what position it needs to, or what value it needs to put in that position to determine that it would be smaller. Then what we're going to have to go is in our number, in the values that we set up for the array, there's only 1, 2, 3, 4. So what is smaller than 2? It's a 1, so it puts a 1 here. Okay. And since 4 and 3 already took the first 2 position, the only number that's left to put in the 4th position is a 2. Okay. And then since the second arrangement starts with a 4 and then it has a 2 as the second position, well, I can't go from a 3 to a 4. That will make it larger, and I cannot repeat the number because it's permutation. So it has to go from 3 down to 2, because our goal in the previous permutation is to get it from 1 to the lower 1. So we would have to go from 4, 3, 1, 2 to 4, 2, 3, 1. Because the 3 and the 1, with the position that they are, it is higher than the next round, which is 4, 2, 1, 3. At this point, it would exhaust the 2 in the second position, then it's going to move it down to the 1. And when it gets to the 1, it exhausted that, then it's going to change the first position to lower, which is a 3. And it puts the 4 here and a 2 and a 1. Okay. And then we would continue with the 3, 4, right, with the 2 and the 1, and then the 1 and the 2. And then it changed the 4 down to the 2. It cannot put a 3 because that would be repeating, since 3 already took the first position. So it has to move it down to a 2, and then put the 4 over here and the 1. Okay. Any question regarding the previous permutation, how it arranges? Just like the other one, at the end, which is the 24th arrangement, that's it. It exhausted all the swap and all the rearrangement as it got to the lowest, which is in ascending sort. Then we have to, when we finish that loop, then it has to go back to the original, which is 4, 3, 2, 1. Okay. Question?
Just to clarify, for example, we're supposed to be using array size 5, right?
Array size 4.
For my lab, it says to use 5.
Oh, yeah, I'm sorry. That should be 4. That's a typo. For number 2?
Yeah. Would you still accept it if I already did it as 5, or should I just
That's
redo it as
fine.
4?
That's fine. You just have one that's gonna not be, it's empty. That's okay.
Oh, I just filled it in with like the 5 and
Yeah,
changed
so
the notation.
yeah, so your arrangement output would be higher. Yes, that's okay. The functionality of it is still the same. So for your calculation for 2a, that will be 5 factorial, right?
Yeah.
So as long as you apply it, I'm fine with that. Okay. So if you have the 5 elements here, everybody, then you have to calculate it for the 5. Sorry, that was my fault. I should have changed it because when I changed the program, I try to make it a 4. So it's, you know, when you output, it's not going to run a lot longer than when you screenshot, it's easier. But I must have not, I forgot to change that. So anyway, if you're using a 5, your calculation would be 5 factorial for A because you would have 5 elements. So you have a larger, right, output as the number of the arrangements. But the mechanism is still the same. You pre-sort it, reverse the sort. So you start with the highest arrangement order, going to the lowest arrangement order in the previous permutation. Okay, now how is it different? Well, you can see the other one is going from low to the highest, where this one going from the highest to the lowest. Visibly, we could see that with the output. Then what I also wanted you to test is just like the other one, we're going to replace the first 2 elements with the higher value. And then we want to run it. And we want to compare it to the original program. Is it drastically different? Is it the same? So the mechanism for the program, the output, right, in such that it will be different because it holds different value that we change. But, you know, if you have the same number of elements, right, it's still going to produce the same number of arrangements at the end. And then it's still going to give you from the highest arrangement order to the lowest arrangement order. Okay. Take a screen capture. So to demo that, right, so here if I put in 21 and 22 for 2C and I run it, I still see that it's still going to give me 24 arrangements throughout. And it started at the highest arrangement order, which is 22, 21, 4, and 3. So automatically when I look at this, I know that the next one, right, based on the previous, so since the 4 take the position here, it needs to go lower, so it needs to go to 3. And then from that, we need to swap it out with the 21, bring it to the 4, the 3, and so forth. So we're still going to get from descending down to the lowest. Okay. So this is using the previous permutation. Any question? We only have to do 4. The last one is a little longer, but. So if you created the number 1 already, then the main change is that it would be this line, and then you also need to change up your function there. That's it. Right? Okay, so no question for 2. Now, at university level, you might be asked to write the program for permutation to permutate, and it really depends on how you would want to approach it, right? Knowing that we saw today that in the STL, we're able to use some of the built-in function, but developer created those. So in the number 4, you see how you can create a permutation program. Okay, so no question on 2? And within the function, you would see that it uses specific operator, right, to be able to compare values as it would iterate through the indices. So now with this one, for example 3, this is when we use is permutation. And again, it's in algorithm STL. So is permutation tests to see if the sequence of the order is, whether the sequence is permutation order or not, okay? And it would use the equal for comparison. Now, if it's the arrangement, if the first range of the permutation that is arrangement and it tested true, it would return true, okay? If the first range, the permutation is otherwise, if it's not the permutation of that set values, it's going to return false. So what do I mean by this? Is that we're going to be able to use this so that we can visibly see how it compares. So in here, we have IO stream, include algorithm because we're using is permutation. In your main, you have 2 arrays. You have one array that's A and another array that's B. And you notice that they have the same number as an entirety. Okay, so I have 1503 and then 0531. Okay. So what we want to do is we want to write an if statement here using the is permutation to compare the values from with B to A. Okay. So here we pass the array identifier, which is A, array A. And we want to check the values in that. So we have 4, so we do a +4 there. And then the third parameter where we would include the array B. So we wanted to see if we can have permutations. This would be a permutation of the values in the array A. Otherwise, it's not. If it's false, then it's going to kick it to else. So when we run this, it's going to check that it is true. So B is a permutation of A. Okay. And if you notice, we have B0531, where I started with A, right? 1503. What if I change this and I put the 0 over here? Okay, let's run it. Sorry, let me put the 1. Okay, So if we rearrange this, we have 5, 1, 3, 0. It would say that it is the permutation of A. Because what it's doing is when it permutate through, it's going to take these values, right, and create arrangement. As long as the arrangement, one of the arrangement is 5, 1, 3, 0, then it's going to check true. Now, if I change this up to another value that's not in it, like a 2, it's going to say false, of course. Okay. Or if I have a repeating number, because in permutation, they have to be distinct. So it's going to check false. Okay. So what you need to do for example 3 is to follow that. Okay. And then using this, I put 5 again, see that? You can do 5 or 4 elements, that's up to you. I'm fine with you doing 5. It doesn't matter as long as, you know, if you do the 4 elements, then like the example, it's still gonna match. What we need to do is, if we're calculating this, calculate the number of arrangement for permutation, is because we want to know the scope, right? How many arrangement that it's going to have. So if you have 4 elements, that will be factorial of 4 again. If you have 5 elements, that will be factorial of 5. Run the program, describe the outcome. So if the values of the array B, 0, 5, 3, 1, if it is one of the permutation of A, then it's going to check it. Yes, that's true. So it's going to output it is. If it is not, then it's going to check it for false. Okay. Any question? Okay, so for 3, we first calculate the number of arrangement by doing n factorial. Then we run the program and describe the outcome. And you should explain it. Why is it checking true? That the arrangement is the permutation of B is, or D is a permutation of A. And then for C, you would change the element values in the second array to be different than the first array. And you saw that, right? If you add a 2 or a different number, then it should be false because it cannot permutate to a different number outside of that array. Take a screen capture, describe the outcome. Any question? And there are many ways to implement, you know, different type of permutation functions in a program. And if you take a look at the example available on the web, you see that, you know, people write it a little bit differently. I try to pick one that's the simplest so you can understand it, because I realize that some students entering this class might not have taken other C++ classes outside of CIS5. So wanted to make sure that it, you know, it is easy to digest, and when you look at it, you kind of see what it's doing. But at the end, you know, you have to write a C++ program for the project incorporating either algorithm or something that would relate to the concept based on the given scenario. So
Hey, Professor, for that project, are we planning to do it in groups or by ourselves this time?
for this class, I mainly give options, because, you know, every time that I teach this class, the student who did it individually, they ended up regretting that they did it individually, because it's a lot of work, right, to be able to put everything together, get it to work, etc. And then, but because I give a survey or team assessment, so I use that as part of the grading too when I grade teams. So again, I think I'm going to use optional group. So if you want to work in group, and I will give you a maximum size, because if you have too large of a group, there's not a lot of work equally distributed. So yeah, so you would have an option to work in group or by yourself, but keep in mind that the industry is about teamwork, right? You develop as a team, you work on project as a team. You know, sometimes you have team members in different part of the world. My cousin, he's a senior Java developer for a company in San Francisco. He previously worked with BitTorrent and LucasArts. And so he tells me that he has team members in Mexico and Brazil and so forth. So they would meet and and he writes library in Java too. So, you know, so you will have an option to work in group in this class for the final project. I will release a final project about week 10, which gives you like 6 weeks to work on it. So as the semester progresses, since I started teaching for MVC, the project came out better throughout the time because quality is better, you know. So I will share with you some sample of the projects so you can see. So I highly recommend, if you're thinking about working with others, find someone to work with, at least one other person, so you can help each other test it, build it, GitHub it, document it, okay? And I'll show you how to use GitHub if you haven't used it before. Any question? Okay. So I'm gonna move on to the last one, okay? Okay, so this one, we are going to write a program that's gonna permutate through string. And if you know, you learn already, right, in CIS5 and other programming classes, is string is a collection of sequential characters. So technically you can treat it as, you know, you can index through it to look at the characters inside that string. You can implement a loop to access each of the character in the string. You can treat it like a collection or a container of different objects within. So what we would have is we would create a permutation function that's gonna access the element in the string, and we're going to be able to switch it. Okay, to give us different arrangement of that string. Okay, so this one, sorry, it gets to the next page as I try to screenshot. It's a little longer, but a lot of the comments. Since we're using rotate, I forgot to mention rotate. Here, it is a way that we would change up the order. This is a built-in function in algorithm STL. So that way that the element, so it says in such a way that the element pointed to the middle becomes the new first element. So it's actually swapping from middle out. So we want to be able to use that so that way it kind of shorten our work a little bit. Okay. So first in this, what you have is you have IO stream, you want to include algorithm. You can put using namespace std so you don't have to add that throughout. And you can create a function, you can call it anything you want, but we want to have a name that would resemble the task for that function. So you can put void permute. Why am I not using string here? Why am I using void? Anyone? So what do you think? Can you use string here? Okay, nobody want to take that?
We're not returning any function.
Yes, that's correct. So simply you're passing. So remember that how you set up your functions here is you have to think about what are you trying to achieve with that function, right? What's the ending output? What's the result what you're trying to get? Okay. So if you would type it if you're trying to return it, okay, and you can use it into other functions in other functions or whatnot. But in this case, we just simply create a function. You can put void, and then the str here is really represent the in, and then the string out. The out is really represent the out. But we want to type it as string because that's we're taking a string and then we would access the character within it to switch it around. Okay. So to start with that, we would say that if the size of the string is 0, right? Just gonna show it and then return. Okay. Then in the for loop really is a way that we would access each of the character. So in C++, the for loop syntax or the format is that we start at the 0. We're going to go up to the size of that string. So if you have a very long string, then you can still go all the way to the end. And remember, it's null terminated. So, and as we go, we would increment. So that's why we have I++ here. And here we would call it, right, permute, which is from the void that we define. And we would start with 1, okay? And then we would have the str with the index 0. So we would move the first character and then we're gonna add it to the out so that way we can see out from the out, okay? So move the first character from the str and put it into the out so we can have it see out, okay? Then we would rotate and we would use a dot begin, and we're gonna go from the dot begin and then every single one subsequent, we would rotate it and then we would get all the way to the end. So in the driver code, then you would assign your string. So we would type it. So here's your input, which is the str, right? A, B, C, D. You can make it longer if you like, okay? Or in the case, if we want to take the user input, let's say that I would present the user, prompt the user, enter your first name, right? And I would input in my first name, and it will permutate through the characters in my first name, and it would give me the variation. Here is your first name scrambled, right? And it would scramble through the number of characters in the first name. So then we would return 0 at the end. So notice that we have, again, 4 characters, very much like the other one. So you have 4 characters inside that string. So to calculate this, we know that it should permutate through, right? It should give you 24 arrangements. So 4 factorial. Okay. Let me get to the program so I can show you. So I started with ABCD, then I get ABDC, ACDB, ACBD, and so forth. And at the end, I get DCBA. Does this look familiar? Does it look like the first program? We're going from lowest to highest in order. Okay. So as you observing on how it compare the character inside that string and be able to permutate by taking out, replacing it with either something lower or higher, you kind of determine on how that function would be. And within this, we actually included the rotation where it would rotate out from, it swap out from the middle. So here is the middle point is our A, B, C, D. Here's the middle point. So it started with C. Okay. And then it would rotate out since after C, I have D, right? I cannot put B because B was in the second position already. Okay, so it moves to D, and so therefore it has to put the C to the last position, the 4th position. Okay, so as you run this program, you would make a general decision on why the outcome is that way. So what I want is after the calculation of your permutation variations, you would create the program, take a screen capture, describe the permutation output in comparison with example 1. Okay. Now then we would edit it and make it 6 characters. How many arrangement do you expect from 6 characters? And what would be the output? So with that, what we do is, so let's say that I add 2 more characters. I would have EF, and you can count this up, it should give you 24. So if I do an EF, right, I'm expected longer, of course, because as you can see there, you have more characters. So I have A, B, C, D, E, F to start with. And then there I would have the following subsequent. So with the 6, that will be factorial of 6. So 6 times 5 times 4 times 3 times 2 times 1. Or you can plug it into your calculator. Okay. And then describe your output. Is it going from ascending to descending or the other way? How is it changing from one permutation to the next? Any question? And if we're not using the rotate here, then you have to implement something to be able to move or swap with the character. Okay, so to capitalize on the STL, then what we can do is we can implement something that already have the functionality in changing or moving the characters. Any question? Okay. Yeah, I should change this. This is not. I originally did do a heap for last semester and the semester before for the C++ program, but they struggle with that. And I realized that not all the student, coming into this class have the heap, concept understood or even learn about it before. So I will let you explore that in CIS 17 C, where they talk about heap and stack. Okay. That is a harder class to attempt, but it's transferable to the university. Okay, so I'm gonna stop sharing so I can check chat. Yeah, so if you don't use, if you use using namespace std at the top, you don't have to type std throughout. So does the last example use lexicographical comparison? Yes. So in order for it to rotate and swap, it does a comparative value, it does. And we're gonna revisit this topic on how lexicographical is being used when we're looking at cryptography. Okay, so we'll come back to that. And also next week, we'll touch a little bit on creating program for combinations. Okay, so once you have your screen capture and your answers, you can put it all in one document so you don't have to upload many times. And you can submit it, but the lab is not due until Saturday. But if you do it today, you don't have to worry about it later on.
Hello?
Yes.
I have a question about the quiz. Is that like in Canvas?
Yes. If you click on the quiz, it will take you to the quiz itself in Canvas. So yeah, you have to use Canvas and take the quiz. You have 3 attempts. So the highest score is going to be recorded.
Okay.
Yeah. And they, if you do the homework assignment, you will be able to understand the quiz questions. Some of the questions we went over in our assignment session, already, right? All the practice questions we've done. So basically cover all the chapters we've gone over.
Okay.
Okay. Oh no. So Antonio, maybe you should try using cloud like REPL or something so that way it's on the cloud. You just have to authenticate, like use your Google credential, which I do. Or you can create an account and then that way it saves it so you don't have to worry about it when it's crashing. So is the extra credit going to help the quiz? The extra credit is going to help your overall grade. I know I see a few familiar people in this class and they know. So throughout the semester, I don't add extra credit until the end. So let's say that you did your project, but there's some deficient score in your project because maybe you forgot your documentation or you didn't do GitHub or whatever it is. I try to distribute some credit to that. Okay. Yeah, so make sure we save. Oh, you lost your document. So maybe use Office 365. Well, you can do the program real quick. They're short. I know it's a pain, but okay. Any other questions? Yeah, if you use Office 365 and if you log into your OneDrive, it just links and saves. So that way you don't have to worry about it. I use Microsoft Team as well. And so on the team, I can link my files. I can also do conference. So it's pretty cool. Doesn't have a lot of functionality like Google, but you know. Yeah, you don't have to output the whole code or just the output is okay for the number 4. Okay, so if you finish and if you want to take off because you already submitted your work, type in your name in case I don't get you, but I usually check. And have a wonderful weekend, right? If you want to attend the STEM event next week, then we have a STEM event where we meet with the students for the mixer, but you know, you can check that out on the announcement. Have a wonderful night if you're taking off.
Thank you.
You're welcome. I'll stick around in case you have questions or you need help. You have a question, Daniel?
Yeah, it was about the e-gift card that you were talking about in the beginning. I got on about 2 minutes right after 6 o'clock, so I only heard the end of it. And
So I'll show you where that is. So in your Canvas for the module, let me see if I can find it now. It's somewhere. Okay. So if you click on module and go to our unit, which is unit 4, I put a quiz review game and it's on quizzes. I don't know if you're familiar with quizzes.
Yeah.
Yeah, so I use it a lot for my games. So the game code is there You just gotta put in the game code, but use your full name so that way I know who that is. Because sometimes students use their whatever device name, and I'm like, well, I don't know who that is to send the gift card to.
Okay.
So at the end, I will get a report on the highest score, and if the person gets the highest score is you, then I will send you an Amazon gift card. It's $25.
It's
You can
a
buy.
it's a game, or it's like a review kind of sheet.
It is a quiz game, so it is a
Quiz game?
review
Okay.
game. Yeah, so if you do well on it, you will likely do well on the quiz. So
Okay.
but the time that you answer matters, okay?
All right.
So
All right.
so if you even if you get all the right answer, and if you answer slow, it doesn't give you as high of a score, and you do have multiple attempts on it. So
Will
the
we be able to see how we compare to others, or no?
yeah,
Okay.
it has a scoreboard, so you would see who's ranking first right now.
When will the extra credit thing of event end actually?
It goes until the 21st.
Okay. Okay. Yeah, we have time.
Yeah, yeah. So try it out, okay?
Okay. Thank you very much.
You're welcome.
Bye bye now.
Bye. Any other questions?